a mixture of slow dances and fast moves. Nice. All right, thank you. So these songs, they have got lots of energy in them, and then this energy we need. Okay, we need this kind of energy before we start something big. So learning is a big thing, and so I want you, okay, to have that enthusiasm and zeal whenever you study. Okay, so this is in a small way, okay, how I can contribute to the environment of this online digital classroom. Okay, so once again, I welcome you all, my dear students who are tuning today to watch this video. My name is Benathang Paton, and I welcome you to the channel Classroom, where we learn together. All right. So today, the topic I have for you is occurrence of metal. So let's start with a very important definition, which is let's define metallurgy first. So metallurgy, M-E-T-A-L-L-U-R-G-Y. What is metallurgy? Metallurgy is the branch of science that deals with the extraction, okay, of minerals profitably and economically. Okay, so it's a branch of science. Metallurgy is a branch of science which deals with the extraction of metals profitably and economically. Okay, so this is metallurgy. It is the branch of science which deals with the extraction of metals. Extraction means removing, okay, from its source, mostly the earth's crust. Okay, so with the extraction of metals profitably and economically. Okay, so this is what you have to know. Then next one, what is the major source? The major source of metal. I have to give you in terms of points. Okay, if I miss out, the flow is affected, so I have to remember the flow. So the major source of metal, the first one is the earth's crust. Okay, this is the major source. Okay, second one is the seawater. Okay, seawater. So this is the second source of the metal. Okay, the next one is how do metals occur? So occurrence of metal. So how do they occur? O-C-C-U-R-E-N-C. Occurrence. How do they occur? Well, metals, they can either occur as elements or they can occur in combined state. Okay, so occurrence number one, metals, okay, occur as elements. Okay, elements means in their free state or native state. Okay, that means they are not mixed with anybody, but they are in their original self. Okay, for example, if the element is B, then okay, it will be found as B only. Okay, not mixed with C or D or E or F. It will be B only. Okay, so this is the meaning of element. After all, the definition of elements are single and pure. Okay, next one, metals occur as compounds. Okay, sometimes they are found as compounds also. Compounds, the definition of compound is two or more elements they join together and give us compound. So compounds means combined state. Combined state, okay. Compound means combined state. So here, two or more elements, okay, will be found together. This is what is the meaning of compound. Compound means in combined state. That means C and G, okay, or D and F, okay, like that. Combined state, na? Or I also, anything, okay. Even CJK, CKJ, CGK, like that. Okay, so three metals are found together. Three metals are found together. Combined state, okay, combined state. Elements found single, whereas if the metals are found in compounds, it will be a mixture of two or more elements. Okay, combined state. Okay. Next, now let's learn some important definitions like what is an ore and what is a mineral. First, let's define what is a mineral. The definition of mineral is very important. Mineral. This definition is very, very important. So, what is a mineral? Mineral. So, the definition of mineral is the elements or compounds which occur naturally in the Earth's crust are or is known as minerals. Okay, so the elements or the compounds which occur naturally in the Earth's crust, which occur naturally inside the Earth's crust, are known as minerals. All right, so this is the definition of minerals. Okay, very important. You have to remember this definition. Okay, but the most important ones will be the next two, which is the definition of an ore and gangue. Okay, so ore, next is ore. Very important. O-R-E, ore. Yeah, the both important. This is very, very important. Let's put 3 marks here. So what is ore? Ore, minerals from which, okay, a metal can be extracted, okay, profitably and economically, is called an ore. Very, very, very important. Okay, so ore ka definition: minerals from which a metal can be extracted profitably and economically. Is called an ore. Okay, let me change my marker. So minerals from which a metal can be extracted profitably and economically is called an ore. Okay, next, gangue. Next is gangue. So present inside the earth, you have got minerals. Okay, and suppose, so you have a mineral with you. Now let's say there are many pieces. Okay, there are many pieces scattered on the ground. You pick up one, and it's this much size. Okay, let's say it's this much size, and then in this mineral you find that majority of the portion is metal. Let's say these shaded ones, these ones are all, these are all what? These are all the metal that you want. Okay, a very precious metal it has. Okay, so this will be called an ore. Okay, and this white part that you see, this white part, this part that you see, this white part. Okay, this is useless part. Let's say this is the useless part which we don't need. Okay, but this bended part, this stripe that you have, these are all important for you. Okay, so this will be called an ore, because 90% or 95 in this example, almost 99%, so 95%, so major portion of the mineral, okay, has the precious metal, so this will be called an ore. Okay, and then this part will be called the gangue. Okay, or the impurity. You don't need this one, isn't it? You don't need this one. Okay, if this figure is too Then let's do like this. Let's do half like this, and let's do like this. This black part, this is the metal, and the gangue is this one. Okay. So the white part is the gangue, the impurity. You don't need this one. So this will be called the gangue. Okay. This is the gangue. So gangue, the impurities present in the, okay, the impurities present in the ore. The impurities present in the ore is called gangue. Okay. So gangue is the impurities. The impurities, IMPURITH, the impurities present. The impurities present in the ore are called gangue. Okay, so what are gangue? Gangue is the unwanted substance. Okay, here gangue will include what? Gangue will include soil, okay, sand, okay, mud, these things. Okay, these impurities which are found present in the ore are called as gangue. Okay, remember the unwanted part which you will throw it away is called gangue. All right, so these are the definition. Okay, then one very important definition, okay, before we go to the next topic, will be enrichment of ore. I hope it's visible. I'm writing down, but then enrichment of ore. What is enrichment of ore? When I say enrichment of ore, it means I mean the increase in the value of ore. So increasing the value of ore. Increasing the value of ore. So what is ore? Ore is the mineral from which a metal can be extracted profitably and economically. That is called an ore. So these are ores. Okay, these are ores. This is an ore. These are ores. So from here the metal can be extracted profitably because majority, more than 50%, okay, say around 70-80% of the mineral is of the mineral contains the metal that you want, isn't it? So this is to extract this one, it is profitable for you. Okay, so these are all ores only. Okay, now after removing the impurity, if you are able to remove the impurity, if you are able to remove this impurity a lot, and then if you decrease the concentration of the impurity to this much, okay, what has happened? You have just enriched the ore. Okay, in the previous state it was like this, it was like this, it was like this. Okay, but now you have managed to remove a lot of the impurities. You have removed a lot of the gangue, and now the amount of gangue is this much only, very little. Okay, that means you have just enriched the ore. You have just enriched the ore. That means you have increased the value of the ore. Now you can sell this at a much higher price. So what have you just done? You have increased the bhav. In Hindi it's called bhav, is not value, bhav, not bhav. Bhav is steam. Okay, bhav. So bhav. So you have increased the value of the ore. This is called enrichment of ore. Increasing the value of the ore. Okay, so now the seller can sell at a higher price, okay, and earn more money. So this is all in terms of business and profit point of view. Okay, so this is what important terms that you have to remember before we go further deep into the lesson. Okay, so next, now we will discuss another very important topic for which I have to draw the diagrams. Okay, so let me draw the diagram and I'll get back to you again. The next topic is extraction of metals. I have already drawn the diagram here, so let me explain to you. So we'll start with this diagram first. So this is the reactivity series of metals, okay, which I have told you to remember. So we have the most reactive element here, which is the most reactive metal, which is sodium, and the least reactive metal, which is gold. Okay, now we have to, okay, to study the extraction of metals, okay, the reactivity series, the metals have been classified or broken into three parts: metals of high reactivity, metals of medium reactivity, and metals of low reactivity. Now this figure is very important. I'll come back to this figure later, but the name of this figure is steps involved in the extraction of metal from their ores. Okay, so we'll be discussing this, but first let me teach you, okay, about this one. So the metals have been divided into three categories. Metals of high reactivity. These five metals, okay, these belong to the first category, this is metals of high reactivity. These are very reactive element. The most reactive metal is here, sodium. Okay, so sodium, potassium, calcium, magnesium, aluminum. These 5, they are so reactive that they are only found in their combined state. Okay, remember, most metals which are very reactive, you will never find them in their free state. Okay, you will never find them in their free state. Okay, you will always find them in their combined state, always mixed with one or the other metal or element. Okay, next is below them, in the middle, we find the metals of medium reactivity. Okay, so they are not that hyperreactive like like this family, or they are not very slow in reactive like below them. Okay, they are in the middle, so these are called middle reactivity, also known as moderate reactivity. I have written MR. It can be middle reactivity or moderate reactivity. Okay, so these 3 metals, zinc, iron and lead, okay, these are metals which have moderate reactivity. And how are they found in nature? They are found in nature in their oxides, sulfides or carbonate form. Okay, then we have below them another set of family which we call as the metals of low reactivity in the far end. Okay, so these 4 metals, okay, they fall under that category of low reactivity. We have copper, we have mercury, we have silver and we have gold. Okay, now these metals, they occur in free state, being very low in reactivity. They are found, okay, they are found in free state. Okay, but there is an exception. Okay, these 3 metals, copper, mercury and silver, they are also found in combined state. Okay, so that leaves behind gold. So we can say that gold, okay, gold will never occur in combined state. Okay, gold and platinum. Okay, though platinum is not shown here, but remember, gold and platinum. Okay, PLATINUM. These 2 metals, okay, they will never ever occur in combined state. They will always occur in free state. Okay, remember that. Though they are categorized, though they are grouped in the category of low reactivity class, I am reminding you, okay, in the family, they belong to the family of low reactivity. But remember, okay, these 3 metals, they occur as combined state also. Okay, they share similarities and properties with almost like this. Okay, they are formed in combined state. Okay, but gold and platinum, okay, these 2 metals, they will never, okay, they will never be found in combined state. They will always occur in free state. So, well, if you become a geologist and then you study rocks and then you happen to find yellow spots, okay, on a rock, well, it can be high possibility that it can be, after being verified, okay, I'm telling you, after being verified, it can be gold. Okay, and if it is gold, you can be rest assured that it is in its free state, it is in its pure elemental form. Okay, so that is the advantage of finding gold. Okay, plus you become rich, isn't it? Okay, so this is what you have to know. Okay, so this is how you study. It's there in the textbook. Okay, these 2 figures are given to you in your textbook, so you can understand this. Okay, this is important. This is how you know from the reactivity series. Okay, this classification is important. Okay, then after this, we immediately study this table. Now this table is very important. So important. Okay, so not the name of a person. Okay, not so, but so very important. Okay, so very important. Remember this. This is important. So this is very important. In my classroom, okay, I tell my students to study this. Okay, this is very important. If you know this, okay, this is the blueprint to the next discussion. In the next video, we'll be discussing in detail, okay, how to extract metals of low reactivity in detail. Then how to extract metals of medium reactivity in detail, and how to extract metals of high reactivity in detail. Now I'm telling you, if you don't have a picture of this, understanding that topic will be a little difficult. So this should serve as a blueprint. This should serve as a picture to understand the next topics. Okay, so first have a clear picture of this. So we have the ore. Okay, we have the ore. Then we do the enrichment of ore. Enrichment of ore, okay, which we just discussed earlier, okay, some few minutes ago, is also known as concentration of ore, okay, which means increasing the value of ore. All right. Then what we do after we are done, we have these three classes, isn't it now? So depending on what ore you got, either this or this or this, you have to select your method. Let's say you got this one, suppose you got this one of these four, okay, then you are here. So you are dealing with metals of low reactivity. So what will you do? Okay, now remember, metals of low reactivity, as per your syllabus, okay, we'll be dealing with sulfide ores only. Okay, we'll be dealing with sulfide ores only. Okay, here it's written sulfide and oxide, but there is no mention of oxide ores in your textbook. So strike out oxide, we'll deal with sulfide only. So sulfide ores, what do? We heat, okay, roasting. What is roasting? Roasting, let me write where there's a space. So what is roasting? So let me just take out the space here, okay? So roasting, very important. So roasting is heating the ore in excess of oxygen, or also known as air. So when we heat the ore in excess of air, it's called as roasting. So the sulfide ore is heated, is burned in abundant supply of oxygen, okay? Okay, so it will react with oxygen and it will give you the metal oxide. So okay, from the metal oxide we heat it and then we get the metal. Okay, after that we just have to refine it. Okay, simple process. Okay, then we go to the metals of medium reactivity, which means any of these three. If you get any of these three, you have to apply this method. Now here, okay, here you will encounter two things. Okay, the metal may be in the sulfide form, because it's written here, is not, they are found as oxides, sulfides and carbonate. So if it is in sulfide form, then you will go for roasting, which is heating the ore in excess of air. But if the ore happens to be carbonate ore, then you will go for calcination. What is calcination? Calcination is the opposite of roasting. So calcination, what is calcination? So it is heating of ore, or heating the ore in limited supply of air. Limited supply of air, which is oxygen. So this is called calcination. It is the exact opposite of roasting. Okay, so the carbonate ores will undergo calcination, which is we will heat it in limited supply of air or absence of oxygen. Okay, after which both the steps will give us the oxide of the metal. This oxide of the metal will further undergo reduction. After reduction, we will go for purification of the metal, and that's how we get the metal. Okay, then how do we extract metals of high reactivity, which means any of these five? How do we extract any of these five? So these are very reactive elements. Okay, so very reactive metal. So these two processes will not work with these metals, okay, with these five metals. So for them, totally different procedure is there. We go for electrolysis of molten ore. Molten means heating them to such a temperature where they melt. Okay, so we'll go for electrolysis of molten ore, after which we'll get the pure metal. So in short, this is just to give you a concept to prepare you before the most important topic, which is when we discuss their extraction in detail. So their extraction will be immediately it will follow after this video. Okay, so in the next video I'll be discussing their extractions one by one. So before that, you should be thorough with this video, whatever has been taught in this video. Okay, so I'll end the class from this. Okay, but before I go, I have a question for you and I want you to answer the question. Okay, give me the answer to the question in the comment box. So the question for today, let me erase this and let me write down the question for today. It's a simple question. Okay, which is the most abundant metal in the Earth's crust? Okay, this is the question. The options are A, what do I give you? Oxygen. B, silicon. C, aluminium. And D, iron. So my dear students, give me the answer. Okay, give me the correct answer in the comment box. So thank you all, my dear students, for tuning in and watching this video. And like I said, the next video is going to be very, very interesting. So please tune in and watch the next video also. So with this note, I'll end the class today, and I'll see you again in the next video.